Hello everyone. I hope you all are doing well. So let's get back to the studies. So before that we will recall what we have done till now. So in numerical methods we have already done interpolation formulas for equal intervals. So for that we have done two formulas, forward interpolation and backward interpolation formulas. So forward interpolation formula is useful if the desired value is closer to the initial point of the given data, and backward interpolation formula is useful if the desired value is closer to the final value or the last value of the data. And the main thing to remember is these two formulas, Newton's forward interpolation and Newton's backward interpolations, are applicable if the given data is of equal intervals. So that a thing you should remember, so that you can distinguish between the so many formulas which you are going to study further also. So for now we have done for equal intervals. Now question comes that it is not necessary that every time whatever data we are having is of equal intervals only. So for that we need to learn the interpolation methods which are useful for unequal intervals. So one of those method we are going to do today, that is Lagrange's interpolation formula for unequal intervals. So today we are going to learn Lagrange's interpolation formula for unequal intervals. So as we know that numerical methods are based on the given data or the available data. So let's start with some data. So let y0, y1, y2 up to yn. These are the entries corresponding to the arguments x0, x1, x2 up to xn. So we are starting with the data. Here you understand that difference between x0, x1 need not to be the same as difference between x1, x2. That is the meaning of unequal interval. So before that, previously what we were having, difference of h everywhere. Here it is not necessary. So we are doing for unequal intervals. So if these are the entries corresponding to these arguments, then the value of y, this is the unknown value of y for any given x. That means this is the given data. We have to find the value of y at any x, which can be obtained by this formula. First time I have written. So y, which is the required value, is equal to x minus x0, x minus x1, x minus x2 up to x minus xn, divided by, I have replaced this x with x0. x0 minus x1, x0 minus x2 up to x0 minus xn multiplied with y0. So here you try to understand the pattern so that we can write the subsequent steps also. So first one we are starting with first entry y0. y0 which is multiplied with x minus x1. What is x? Which is the value at which we have to find y. So we are subtracting the remaining values from x. x minus x1, x minus x2. Which value we have left? Corresponding to y0. That means x0 we have left. Divided by, now we have replaced x with x0 in every term, every factor. So based on this pattern, now we will write next value. So y0 we have used. Now which one I have to write? I hope you are trying to write it before me, or at least you try to say it with me. So which one should come here? y1. So if I write y1 here, now which value I should leave? For the y0 we have left x0. So now we will leave x1. So starting with x minus x0. Now x minus x1 will not come. So that next one will be x minus x2 up to x minus xn, divided by, now x will be replaced with x1. So x1 minus x0, x1 minus x2 up to x1 minus xn, plus, like that we will keep writing the values, and last one will be corresponding to yn. So if I write yn here, now which value I should leave here? xn. So I have to start with x minus x0, x minus x1 up to when? xn will not come. So what is the value before xn? x n minus 1. x minus xn minus 1 I can say, divided by x will be replaced with xn minus x naught, xn minus x1 up to x minus xn minus 1. So this is the Lagrange's interpolation formula for unequal intervals. Okay, so here you can see that we have not made any table. No difference table is required here. Whatever the values are given, we have directly used it. So you can say this is simpler one if you find that you need not to make any table. So that is the difference also. Second thing, we have how many times we have to write this table? If suppose only 4 values are given in the question, up to y4. So as per the given data, we have to write these values and then simplify whatever value you are getting for this x, that will be the value of y at that given point x. Okay. Second thing, if suppose I do not substitute any value here, I hope you know that x0, x1, x2 up to xn and these y0, y1 all are numerical values. So these will be, some data is given, some numerical values are given, and if I don't write any value of x here, then without substituting any value, if I simplify right hand side, what will I get? If I multiply all these brackets and simplify, what will I get? I will get the value in terms of powers of x, polynomial in x. So if I simplify that and get a polynomial, that method is known as fitting the polynomial. So if question is fit the polynomial, in that case we don't substitute any value of x and we simply simplify that. If any particular value is asked only, no fitting of polynomial is asked, then we directly substitute the value and we find the desired value of y. So these two questions, that fitting the polynomial and finding the value, that we will understand in two examples. One by one we will take two examples and we will try to understand it.